Hello, this is a presentation on triggers, procedures and function and also the date function. So the topics to be covered in this presentation are introduction to triggers, privileges required for creating the triggers, types of triggers, syntax and working with these triggers, introduction to the procedures, privileges required for creating procedures, procedures and functions differences, syntax and working with these procedures and functions, date function introduction, and format and working with these date function. So now let's have a brief introduction of trigger. So what is a trigger? Trigger is nothing but it defines an action the database must take when some database related event occurs. So this database related event may be a data manipulation statement such as delete, insert or update, or it can be a database definition statement such as create, alter or drop, or it even can be a database operation such as log on, log off, startup or shutdown. So what is the necessity of these triggers? Triggers have a vast variety of uses. So a main important uses of these triggers are it enforces the referential integrity constraints and also enforces the complex business rules. Because of their flexibility, triggers are used to supplement referential integrity, but they should not be used to replace it. When enforcing the business rules in an application, we should first rely on the declarative referential integrity available. Use triggers only to enforce rules that cannot be coded through the referential integrity. The code within the trigger body is made up of PLSQL in Oracle 11g. So when are these triggers executed? Triggers are executed by the database when specific types of data manipulation commands are performed on specific tables. So required system privileges are whenever we want to create a trigger on a table, we must either own that table or have alter privilege for that table or alter any table system privilege. In addition, we must have the create trigger system privilege while creating the table. If we are creating triggers in other user schema, we must have the create any trigger system privilege. To alter a trigger, we must either own the trigger or have alter any trigger system privilege. Then, for creating a database level event, we must be the administrator database trigger system privilege. When triggers are created, a trigger may reference table other than the one initiated the triggering. So we must also have the privileges to insert into the referencing table also. So types of triggers. The triggers can be defined by the type of transaction, triggering transaction, and by the level at which the trigger is executed. So by the level at which the trigger is executed, the trigger is classified into two types, that is a row level trigger and the statement level trigger. Row level triggers execute only once for each row affected by a DML statement. For example, if we are inserting say 50 rows into a table, the row level trigger executes once for every row being inserted. That means it is going to execute 50 times. So as it is executing for every data being inserted, so it is very useful for keeping distributed data in sync, and it is the most common type of trigger being used. So to specify a row level trigger, we use for each row clause in the create trigger command. Statement level triggers. Statement level triggers execute only once for each DML statement. That is, if we are inserting 50 rows in a table, it executes only once. So this is not often used for data related activities. it is used only to enforce additional security measures on the type of actions that may be performed on the table. By default, in a create trigger command, it will be a statement level trigger itself. So before and after triggers. Triggers are executed by event. So we have to set the triggers to be executed either before the event occurs or after the event occurs. Since the events that execute triggers include database DML statements, triggers can be executed immediately before or after inserts, updates and deletes. But for database level events, we cannot create the trigger before login, before startup. So there are some restrictions for database level events. We can create trigger only after startup, after login. And within the trigger, we can reference the old and new values involved in the DML statement. The access required for the old and new data may determine which type of trigger we need. For example, old refers to the data as it exists prior to the DML statement. So updates and deletes usually reference old values. New values are the data values that DML statement creates. So it is going to be the newly inserted values. Instead of triggers, we can use instead of triggers to tell Oracle what to do instead of performing the actions that invoked the trigger. For example, we could use an instead of trigger on the view to direct the inserts into a table or to update multiple tables that are the part of the view. So it is very helpful because it doesn't restrict us for updating or inserting into the views. It is going to update all the tables or in all the tables that are underlying the views. Then the code in the instead of trigger is executed in the place of the event, that is the insert, update or delete, whatever command we have given. Then comes the schema triggers. We can create the schema level operations, triggers for schema level operations such as create table, alter table, drop table, audit, rename, truncate and revoke. We can even create a before DDL trigger. For most part, schema level triggers provide two capabilities: preventing DDL operations and providing additional security monitor when DDL operations occur. Next comes the database level triggers. We can create triggers to be fired on database events including errors, logins, logoffs, shutdowns and startups. This type of trigger are used to automate database maintenance and auditing actions. So next are the compound triggers. The Oracle 11G provides us combining multiple types of triggers in a single compound trigger. We can use a compound trigger to perform calculation and processing that would not be possible if the triggers were executed separately. We can use the compound triggers to share variable values among various triggering commands and avoid mutating table errors. So next comes the trigger syntax. This is the trigger syntax for creating. So we use here create line, the or create or replace. The or replace is an optional. Then we need to specify trigger, and if we are creating in other user schema, then we have to mention the schema, then dot, then the trigger name should be specified. Then we must specify whether this trigger is going to be executed before, after, or it is an instead of trigger. Then comes the what type of database related event it is, whether it is a DML event, that is insert, delete or update, or it is a DDL event, that is create, drop, or it is a database event, that is login or log off. Then we need to specify on which database it is going to occur, that is if it is in other user schema, then we have to mention the schema, then dot, then comes the database, that is we need to specify the table in here. If it is in other user schema, we need to mention the schema name also. Then we need to specify the when condition. The when condition restricts when the trigger block is going to be executed. Then comes the PLSQL block, that is this PLSQL block contains what is done through this trigger. Now let's see an example for creating a trigger. First let's create a bookshelf audit table, which is the same as the bookshelf table. We have already created the bookshelf table with the same attributes. Now we are creating the bookshelf audit table with the same attributes as that of the bookshelf table. Then here is the trigger. So create or replace, this is or replace is an optional. Create or replace a trigger. Bookshelf before update row, this is the name of the trigger being created. So now we are mentioning whether it is going to be executed before, after, or it is an instead of trigger. So this trigger is a before. We are going to execute this trigger before the event, that is the update event, and on the bookshelf table. So whenever the update operation occurs on the bookshelf table, before that we need to execute, the computer needs to execute this block of code. So here for each row clause is there. This is going to specify whether it is a row level or a trigger, row level trigger or a statement level trigger. Then comes the when condition. This when condition checks before executing a trigger. So here the new rating the given is compared with the old rating. If the new rating is smaller than the old rating, only then this trigger is going to be executed. If new rating is equal to or greater than old rating, then the trigger is not being executed. So then this PLSQL block explains begin insert into the bookshelf audit table. Whatever we are trying to insert in bookshelf table, the same will be inserted into the bookshelf audit table. See, insert into bookshelf audit table, and the values we are specifying here old, that is we are not taking new ones, as it is an update operation. If it was an insert operations, these values would be new. Then end with the slash. The trigger is created. Sometimes trigger created with compilation error, you are going to get the result. That means your trigger is not being executed or created properly. So the example here I have shown is, see, one row I have updated, that is bookshelf. I have set the ratings equals to, I have set the rating equals to 3, where book title is equals to Oracle 11G. Previously, see, old rating was 5, new rating is 3. So when this update operation occurs, the trigger is going to execute the same rating also into the bookshelf table along with its all the attributes. See, the Oracle title book is inserted, the publisher is inserted, the category name, old value, new value, and also the audit date is being inserted. Combining DML trigger types. So triggers for multiple insert, update and delete commands on the table can be combined into a single trigger, provided they are all at the same level, that is either a row level or statement level. They must be at the same level. In this trigger, it is executed for two types of event, that is insert or update, and both are at the row level and both are executed before event occurs. So here is a if statement in the PLSQL block that specifies whether checks whether it is an inserting or else it is going to be the update, because here only two are there. Otherwise, if insert or update or delete was there, we could have used if inserting, if updating, else command like this. So here if is going to check whether it is an inserting. If it is an insert command, then this block is going to be executed, that is it is going to be inserted in the bookshelf audit table. Else it is going to be inserted in the bookshelf audit table only. Then end if, and then the trigger is created. Here as we have used if clause, we have to mention end if statement here in the PLSQL statement. As the update was same as the previous example shown, I am going to show here only the insert command. So we are inserting here into the bookshelf. So as it is, the trigger is going to be executed, and the values from here are going to be inserted into the bookshelf audit table. So here before only Oracle 11G was there in the bookshelf audit table because of the previous updation. Now even the DBMS which is now is inserted is also in the bookshelf audit table, but here old value is not there. It is because we are not going to insert any old values here. We are going to insert only new value. So setting the inserted values, we can use the triggers to set the column values during the insert or updates. So here is an example that stores an uppercase version of a value along with the mixed case version entered by the user. Because the uppercase version of the value is a derived data, it may become out of sync with the user entered column. Unless our application supplies a value for the uppercase version during inserts, the column value will be null when a new row is entered. So to avoid this synchronization problem, we can use a table level trigger and then put a before insert and before update trigger on the table. This will act at the row level. To demonstrate the setting of inserted values, here we are going to create a table, that is the bookshelf checkout table, which contains the 4 attributes: name, title and checkout date and return date. Then we are going to insert values, that is a name as ABC and title as DBMS and return and checkout date here. Then we are going to alter that table, alter this bookshelf checkout table, and we are going to add a upper name, another attribute as an upper name. Then we are going to create a trigger named as bookshelf checkout before insertion on the row. That is, we are going to create a trigger that is going to be executed before insert or update on the update of the name. We are even going to mention which attribute on the bookshelf checkout. So for each row it is going to be a row level trigger. Then begin new dot upper name. This is the value being accessed. So whatever new dot upper name is being set will be set to upper case of the, this is uppercase. This converts whatever the mixed case values given by the user into uppercase values into the uppercase values. So this is the new dot name given by the user. So end. Now we are inserting values into the bookshelf checkout table. We are inserting name as Ria. We are entering the name as Ria. Then Oracle 11G is the name of the book. Then return date, checkout date, and also we are given the upper name. But see, when it inserted into the bookshelf checkout table, what it is going to be inserted as Ria, the uppercase value here only. See, this is the name and this is the upper name. As I have given all this as an uppercase, it is given in the uppercase only. In this example, I have given in the small letters the name, and the upper name is converted into the caps lock and being inserted. With now customizing error conditions. Within a single trigger, we can establish different error conditions. So for each of the error conditions, we have to define a error message that appear when the error occurs. So the error numbers and the messages that are displayed to the user are set via the raise application error procedure, which may be called within a trigger body. Here we have created a statement level trigger, which is being executed before the delete event occurs on the bookshelf table. So here in the PLSQL block, we are declaring we are creating two exceptions. One exception is a weekend error and the another exception is a not library user. Then we are beginning what must be executed. So if toChar SYSDATE, that is dy is a date function, date format that extracts only the 3 characters D function from the total SYSDATE. So it would be either MON, that is Monday, TUE, that is Tuesday, or SAT as Saturday. So if it is equal to Saturday, or toChar SYSDATE dy equals to Sunday, then raise the weekend error. Now end the if statement. Next, again start the if statement for checking if the substring of the user from 1 to 3 characters are not equals to lib. Then raise not library user, that is this function extracts 1 to 3 characters from the user name, and if that first 3 characters are not beginning with lib, then we are raising the not library user exception. So end this if. Then here we are going to define the exceptions. So one weekend error, then what we should do? Raise the application error. This is the procedure what we are calling within a trigger. So -1 or 20,001, this is the error number to be displayed, and this is the message to be displayed, that is deletions not allowed on weekends, that is C, Saturday and Sunday. If it is equals to Saturday and Sunday, then deletions are not allowed. Then similarly, when not library user, raise application error, the number displayed will be 220,002, and deletions not allowed by the not library users, that is only library users can delete the things. So the trigger is created. So example here, in this example we are trying to delete from bookshelf table where title equals to DBMS. So As I was not the library user, the 20,002 with the message is being displayed. Deletions only allowed by the library users, and see the number here what we specified, 20,002. And it is also specifying which trigger is leaded to this error. Then comes the naming of the triggers. So when we are naming a trigger, the trigger must clearly indicate what table it is being applied to and what are the DML commands that are triggering this event. Then it must be either executed before or after, and whether it is a row level trigger or a statement level trigger. So, but the trigger name cannot exceed the 30 characters in length. So we have to use the standard abbreviations. See here, we cannot just specify before, update, row, level fully here and then mention the book checkout table in a small size. Instead, this is the wrong way. Instead, we can do it as we have to mention the bookshelf checkout table name completely. Then BEF is used as abbreviation for before, UPD is used as abbreviation for update, and row is used for the row level trigger abbreviation. So this is the correct format. We can create triggers that are executed when a DDL event occurs. DDL event is nothing but data definition language. That is, for example, create, alter and dropped commands on either cluster function, index, package, procedure, role, sequence and many other things, or even the views. So if we are planning to use this feature solely for security purpose, we can even go for audit command. We can use this on SCHEMA class. The trigger will execute for any new data dictionary objects created in our schema. To protect the objects within a schema, we may want to create a trigger that is executed for each attempted drop table command. So here we have created a drop table trigger for drop on the schema Scott. Then here in the PLSQL statements we have mentioned if the Oracle dictionary object owner is equals to Scott and Oracle dictionary object name is something like Boo, that is it begins with Boo and it continues, we don't know. Then Oracle dictionary data object type is equals to table, then raise application error. The error message number will be 20,002 and the message is operation not permitted. So we are preventing the table starting with Boo in the user schema Scott to be dropped. So here let's try here, drop table bookshelf audit dupe. See, this schema is Scott schema and the bookshelf table that is starts with Boo and it is a table, so it is not allowed. See, error is thrown here 20,002, that is operation not permitted, and it specifies error occur at recursive SQL level because it is an SQL level. Now creating compound triggers, that is as of Oracle 11G we can create a trigger that has a section for each of the following, that is before statement, before each row, after each row and after statement. So Oracle 11G is providing us the ability to combine statement level and also the row level trigger commands in the same trigger. So it performs a complex commands that share data at the statement and row level when performing processing. As a result of this, we can avoid mutating table errors and hence we can improve the performance and efficiency. So a compound trigger has a different section. It has a section for each of the 4 above mentioned statements. And all the state information are shared in between them. When the triggering statement completes, the state information is no longer available. So enabling and disabling the triggers. For declarative integrity constraints, it are being enabled and enforced for every rows possibly in the table. But as for triggers, they are not necessarily affected to all the rows in the table. They are affected only for the specified type and only when they are enabled. By default, a trigger is enabled when it is created, and any data prior to the trigger's creation will not be affected by the trigger. So there are times when we don't want the trigger to be executed. So the two most common reasons involve the data loads. During large data loads, we may want to disable triggers that would execute during the load. Disabling the triggers during the data loads may dramatically improve the performance of the load. Hence, we will disable the trigger at that time. And after the data has been loaded, we can just manually perform the manipulation which was performed by the trigger. So the second reason would be the data load related relation. The second reason is data load related reason for disabling a trigger occurs when a load fails and has to be performed a second time. In this case, it is likely that the load is partially succeeded in loading, but the trigger was executed for the part of the portion. But when we are, as it has the loading is failed, when we are trying to reload it, the trigger is executing again for the part which was already being executed. Hence, at that time, we don't want the trigger to be executed twice for the same insert operation. Hence, we disable the trigger and do the manual manipulation which was done by the. So, if a trigger is disabled, we can enable it through the alter trigger command. To alter the trigger, we must have the alter trigger privilege or alter any trigger privilege in that system. Alter trigger, this is the trigger name and we have enabled it. Or we can do it as alter table, enable all triggers. If we don't know the name of the trigger, only one trigger, we can enable all the triggers. Similarly, we can disable it. We can mention a single name of the table and disable it, or we can mention, say it as all triggers disable. The last part in this triggers is replacing and dropping of the triggers. As of the replacing triggers, in the create syntax table, there was create or replace trigger statement. As I said, or replace is an optional. If the trigger is already created and we have some modifications in that existing trigger, we can use create or replace trigger in that and mention the new trigger there only, then the trigger body is altered. Then the dropping triggers is nothing but just a simple command, that is drop trigger command is going to drop a trigger. And to perform this drop operation, we must either own the trigger or we must have the privilege as drop any trigger system privilege. The next topic is procedures and functions. So now let's have a brief introduction of the procedures. So what are the procedures? In Oracle, the sophisticated business rules and application logic can be stored as procedures. The stored procedures are nothing but a group of SQL or PLSQL and Java statements which enable us to move code that enforces business rules from our application to the database. Hence, the code will be stored once for multiple applications. Because Oracle supports stored procedures, the code within our application can become more consistent and easier to maintain. Here also, while creating the procedure, we require certain system privileges. So we need a create procedure system privilege for creating a procedure, and if the procedure object will be in the other user schema, then we need create any procedure system privilege, and once the procedure object has been created, it may be executed. But when a procedure object is executed, it may rely on the table privileges of its owner or may rely on the privileges of the user who is executing it. When the procedure is created using the definer rights, that is the one who is creating the procedure, his rights, then a user executing the procedure does not need to be granted access to the tables that the procedure is accessing. But when the procedure relies on the invoker's right, that is the one who is invoking that procedure, the user must have the access to all the tables or database objects accessed by that procedure. And now, to allow the other users to execute our procedure object, we have to grant them the execute privilege. So the syntax for this execute procedure depends on the environment from which the procedure is being called. If it is called from SQL plus, then it can be executed using simple execute command followed by the procedure name. So we are just giving them grant execute on the procedure name to the name of the user. Then from within another procedure, function or package or trigger, the procedure can be called without the execute command. For example, in the trigger we just simply call the procedure by using the call statement. Call procedure name and followed by the arguments. To execute a procedure owned by another user, we must either create a synonym for the procedure or reference the owner's name during the execution. The owner of that synonym would then no longer need to be referred to the procedure owner execute the program procedure. For example, we are creating here the synonym for the new book in the user schema as new book. So if the synonym is created, we can then directly call it as call new book procedure. Otherwise we have to call it as call scott.newbook. And we can also execute remote procedures. The name of a database link must be specified and the name of the database link must be with @ symbol. To make the location of the procedure transparent to the users, a synonym may be created for the remote procedure also. So the table privileges required for procedures are: one procedure may reference more than one table. So for the objects to execute properly, the owner of the procedure, package or function must have privileges to use that table. Unless we are using invoker rights, the user who is executing the procedural object does not need any privileges on its underlying table. So what is the difference between procedure and functions? Procedures and functions are same, but only with one difference is that function returns a value to the caller and functions can be directly referenced in the queries. But procedures do not return any value to the caller, and the value is returned through the use of the return keyword within the function syntax. Here is a create procedure. We are creating a procedure with the help of create syntax here as follows: create or replace. This is an optional, or replace is optional. Then specify procedure, then specify the procedure name. If it is we are creating the procedure in other user schema, then we have to mention the schema name also. Then we have to pass the arguments for this procedure. So the arguments would be in the form of in, out or in, out. So here in qualifier is used for, it specifies that the values must be specified using the calling. The in qualifier here specifies that we must specify the values while calling the procedure, and the out qualifier specifies that the procedure passes a value back to the caller through this argument, and the in out qualifier specifies that the procedure takes the argument that this procedure must be specified with a value when it is called, and the procedure will return a value to the caller via the argument. If no qualifier type is specified, then the default value is in. In the create procedure syntax, the author refers to the type of authentication, that is definer rights or the invoker rights. Here definer rights is the default and the invoker rights will be mentioned, need to be mentioned. The no copy variable used here specifies that tells to the oracle to pass the value variable back to the user as quickly as possible. As it is an oracle, it contains the PLSQL subbody. In others, it may be even the Java, C or any other library names. Here firstly we have created a book order table which contains title, publisher and category name. Then we have created the procedure named as new book, and we are passing it the arguments as a title, a publisher and a category, which are all in that which specifies the value must be specified while calling the procedure. Then begin, we will insert into bookshelf. The same whatever we have the arguments passed here are going to be inserted into the bookshelf table, and then they are going to be deleted from the book order table, where title is equal to this title. So according to this trigger, we are inserting the values passed through this procedure into the bookshelf table, and we are going to delete that values from the book order table. The executed example is here. Firstly, we are seeing what are the contents of the book order table. Here DBMS, Java and web are the contents of here the book order table, and bookshelf table contains DBMS, Oracle, 11G and the OS. Now execute this new book and pass the arguments as web, Pearson and these things. Procedure successfully executed. So next we select the book order contents. Here we are going to get only Java and DBMS. Web is missing here. This web instead is inserted into the bookshelf table. Next, create function syntax. Here it is also same. We are creating or replace is an optional function name. If it is in the other schema, then we have to mention the schema name. Then we need to even pass the arguments which contains the same in, out or in, out qualifiers, where in specifies that the value must be specified while calling the function, and out specifies that the value will be returned from the function, and in out specifies that the value must be passed during the function calling, and the function will return the value through that qualifier. And no copy tells that Oracle to process as quickly as possible. Then the extra addition from procedure into the function is the return statement here, and the data type specified. The return statement returns the value from this function into the data type specified. Then here the same it is there, invoker rights clause, or it is the that is whether the function is being executed from the invoker rights or from the definer rights. And then here in the PLSQL function body, what needs to be done is specified. Example for the function here is, we are creating the function named as overdue charges, and we are passing the arguments a name and in varchar data type. So return something into the number data type. So here we are, when declaring the owed amount, variable as a number. Then select the sum. We are calculating here the sum of return date minus the checkout date. We are subtracting the return date and checkout date. Then from that we are subtracting 14 and we are multiplying 20. That is, for each day after the 14 days we are adding 0.20 as a fine into owed amount from bookshelf. The calculated sum is stored in the owed amount. This is calculated from the bookshelf checkout table, where here the name specified is taken and we are returning the owed amount. Initially we are looking into the bookshelf checkout table, their contents. So here are the three names, ABC and Rhea, and here checkout date and return date is being seen. So here we are executing this function as execute owed equals to owed charges Rhea. We are specifying the name here. Overdue charges is a function name. We are calling it, and the procedure is executed successfully. Now we can see the owed as print owed. We can check it. The SQL plus show errors command displays all the errors associated with the most recently created procedure object. This command checks the user errors data dictionary view for the errors associated with the most recent compilation attempt for the object. The show errors displays the line and the column number for each error as well as the text of the error message. To view errors associated with the previously created procedure object, we may have to query user errors directly. Rather than just calling custom functions via execute commands, we may just use them within the SQL expression. This enables us to extend the functionality of SQL, customizing it to our own needs. So such functions can be used in the same manner as Oracle provided functions such as a substring or toCharacter. First, customized functions cannot be used in check or default constraints and cannot manipulate any database values. We can call either standalone functions or functions declared in package specifications. Procedures are not directly callable from SQL but may be called by functions we create. So customizing the error conditions, similarly as with the triggers, we are customizing here with the use of procedures. We may establish different error conditions given within the procedural objects. For each of the error conditions we define, we have to select an error message that will appear and also the error number that will be displayed. So both these error numbers and messages that are displayed to the users are set via the raise application error procedure, which can be called inside any procedural object. So it requires two inputs. One is the message number and the other one is the message text. We get to assign both the message number and the text that will be displayed to the user. So in this, we are creating the function called as overdue charges and passing the name as the argument. Then we are returning the number. Here owed amount, as previously as I said, owed amount is declared. Then same, the owed amount is calculated, and if the return date and checked out is smaller than 14, return owed amount. Exception, when no data found, then raise application error as no books borrowed. So if the name is not found, then this error is thrown. So as we named the triggers, we need to name the procedures and functions in the manner of what they perform. So procedures and functions perform something, so we need to mention what they are performing. So as previously we have used just new book this is a wrong way of specifying. We need to specify what they are doing, that is the receive, then the book order, the table on which they are being executed. Viewing source code for procedural objects. So the existing procedures and functions source code can be queried from the data dictionary views. So there are three types of data dictionary views, that is user source, all source and DBA source. From user source, procedural objects owned by the user can be queried. From all source, procedural objects owned by user and for which he is granted access to can be accessed. Then DBA source for all the procedural objects in the database. So here is an example where we are querying the procedure named as new book from the user source, that is only which I have created, where the type is the procedure. Then it gives the output as the text and all what we have been created. Then compiling procedures and functions. Oracle compiles procedure objects when they are created. However, procedural objects may become invalid if the database objects they reference may change. So the next time the procedural objects are executed, they will be recompiled by the database. So to avoid this runtime compiling and the performance degradation, it may cause by explicitly recompiling the procedures and functions. To compile a procedure, use the alter procedure command. So the compile clause is the only valid option for this command. To recompile a function, use the alter function command with the compile clause. So here we are going to compile the new book procedure explicitly using the alter procedure command with the compile clause, and even the function with the compile clause. We need to have the alter privileges for both procedure and functions if you want to compile explicitly. Then dropping procedures and functions. Similarly with triggers, procedures and functions can be dropped with a simple drop procedure command and drop function command. And we need to either own the procedure and function, or we need to have drop any procedure system privilege to drop both the procedure and functions. The date function introduction. So one of the Oracle's strength is its ability to store and calculate dates, and the number of seconds, minutes, hours, days, months and years between the dates also is being calculated by the date Oracle. In addition, from the basic data function, Oracle supports a wide array of the time zone conversion functions. So here are some of the format and their meaning. If we specify only D, it means the day of the week. If double D is specified, it means day of the month. If triple D, then it specifies day of the year. If DAY day is specified, then full day, for example Monday, Tuesday, fully it is specified. If only DY is specified, then only 3 letters from the day are extracted, that is from Monday only MON, from Tuesday only TUE is being extracted. And if W, it means week of the month, which week. Then double W means which week of the year. Double M specifies month in 2 digits, that is 1 for Jan, 2 for Feb and 12 for December. Then MON specifies month in 3 characters like JAN, FEB, APR, etc. Then MONTH specifies full month, January, February, April, etc. The RM format specifies month in Roman characters, that is 1 for Jan, Roman 2 for Feb, Roman 12 for December. Q specifies quarter of the month. Double Y specifies last 2 digits of the year. Triple Y specifies full year. YEAR specifies that is years in the word, that is 1992. Then double H specifies hours in 12-hour format. Double H 12 also specifies hours in the 12-hour format. Double H 24 specifies hours in the 24-hour format. And MI specifies minutes, SS for seconds, FF for fractional seconds, and Fibal S for milliseconds. We have the functions for accessing the dates. SYSDATE, Oracle taps into the computer operating system for the current date and the time. through the SYSDATE function call. So select SYSDATE from dual extracts the current time from the operating system. Current dates reports the system date in the session's time zone. Next comes the sys timestamp. Reports the system date in the timestamp date format. That is, timestamp date format is nothing but it includes date, month, year and also the time zone. Then it comes with the hour, minutes, seconds and milliseconds, and also the time zone, that is +53 time zone, and it specifies whether it is an AM, PM or whatever. It has the full date function. Here for the further examples we have considered a table as holiday, where we are specifying holiday, actual date and the celebrated date. So there is in the previous considered example there is a difference between the actual date and the celebrated date in few of the dates. So we can add months here. So add month is the function in the dates that is going to add the months. So select add months, celebrated 6. Here 6 is going to be added as for the fest day is concerned in the holiday, where it is told is like fast. So it is printed as a feast day. It was previously celebrated on on March. March plus 6 months is going to be this answer. So it is the August. So 6 months is being added to the actual date from the holiday table. Then subtracting months, it has same function, add months, but only thing is here we specify 6 positively and here we specify -6, indicating minus operation, that is subtracting. So same here in the way Columbus Day is extracted and 6 months is being decremented. So here April is printing, otherwise it was actually in October, but here we are printing April, that is 6 months prior. And similarly with fast, it was in February and we are printing it as August, because here 6 months is added and here subtracting 6 months is deleted. Then greatest and least values. Here 2 dates are considered, actual date and celebrated date, and among them whichever is the least is selected with the help of the least date operation. So here they are printed as first, the least between actual and the celebrated date as printed as the first, and actual and celebrated date are printed next. From holiday, where actual date minus celebrated date is not equal to 0, this must be satisfied. See here, from this actual and celebrated, least is 15 Jan, so it is taken here, and here 12 and 16, 12 is there, least, this is taken here, and 22 and 16, least is 16, so this is taken here. Similarly for the rest too. Again, for the further things, for the further date function, we have considered another table as payday table, which has 15th, that is exact middle date of each month. For next day function, the next day function computes the next date of the next named day of the week after the given date. So here select last date as SYSDATE as a month. The next date function computes the date of the next named day of the week after the given table. So here the next day is calculated in the cycle date as Friday as the payday from the payday table. So for payday everything was 16. It next date for everything is calculated, next date of the next name day. Then the last day produces the last date of the last day of the month. So here last day function is spelled in as the last cycle date in the payday table. So for every month the last day is being printed. So again we have considered a birth date table where first name, last name and the birth date is taken, and then we here have combined two or more functions. For example, here we have combined both the last date function and the add months function. But firstly here add month function is executed because it is the inside of the braces, and before that the SYSDATE is function is executed. SYSDATE comma 6 is executed, that is 6 literals is being extracted from the SYSDATE table, and then to this we are adding add months. Then the last date table, the last date function is being executed and it is printed as review here. Last date plus 1, we have missed this plus 1, so last date of that month plus 1 will result in the next month first date. And again similarly we have combined another 2 here, last date, add months, again 6, but we have again made here SYSDATE minus we have done. So what is the result is we are getting a integer here, not the date function, because SYSDATE we are extracting 6, then we are adding the months, then for the last date we are adding again 1 day, but then we are minusing the SYSDATE, so it results into the number of days between them. Two char and two date formatting functions here. To date converts a character string or a number into a oracle date, but whereas to char converts an oracle date into the character string. It is both the reverse ways. So the format for these two functions are to char, we need to specify date, then the format, then NLS parameters. Then similarly to date, it is opposite, we need to specify a string. The input is string here. Then the format, NLS parameters. Date is a date data type as we know, then string as a literal string or a database column that contains a string or a number, not a oracle specified date format. Then a format is a collection of many options that can be obtained in virtually an infinite number of ways. And NLS parameters is a string that sets the NLS date language option to a specific language as opposed to using the language for the current SQL session. And the example here is given. We are converting to char. The birth date is given and it is given in the string, not in the oracle format. Then it is printed here. The output is printed here. New time switching time zones. The new time function tells you the date and the date of a date column or literal date in other time zones. The format for new time is new time, date, this and other is going to be specified as the parameters. Date is a day in this time zone, then this will be placed by the 3-letter abbreviation for the current time zone. Other will be replaced by a by a 3-letter abbreviation of the other time zone for which you would like to know the time and date. Example here is the date is given for the new time function. A date is given, a 3-letter format of the present time zone is given, then the 3-letter format of the time zone we wish to see the time is given and it is printed here. Two date calculations. So As I said, the purpose of it was to convert a literal string into an oracle date format. Even we know the syntax for a toDate string and the format. So toDate function, we are giving a string. This is not in the oracle format. Then for which format we want, we have specified here. So it is going to be printed in that format itself. Restrictions of the format that govern toDate. No literal strings are allowed, such as baby girl on the literals we cannot specify. Days cannot be spelled out, they must be numbers. Punctuation is permitted. FM is not necessary. If used, it is ignored. If month is used, the month is in the string must be spelled out. If MON is used, the month must be a 3-letter abbreviation. Uppercase and lowercase are ignored. Days in where clause. So between operator will do date arithmetic. So in the example here, the between keyword is used in the where clause, which calculates the number of dates between the 2 days specifies. Then the in operator works well with the literal strings also. So here it is not in the format needed. So in here, this or this, when the in format is taken, if one of this is specified, it is printed. Using the extract function. So extract function is used in place of the toChar function when we are selecting portions of the date values. Only when we want some part of the date values, not whole part. So the extract function syntax is extract year, month or day, hour, minute or whatever part from the time zone or time minute or the time region or the time zone abbreviation we need to perform from the date value expression must be given. So example here is, we are extracting month from the birth date. Here we are extraction function is used in the select statement itself, where we are extracting month from the birth date as only just month here, then we are printing it. So month is being printed. These are the references of my presentation. Thank you.